Today we will talk about the project 3, although it's the homework 8. We will use the data for this task. And you can download a zip from Blackboard and then extract it. And you will see there are 3 folders inside. For each folder, we will have 4 little folders. And there are some data inside. For example, for this, we will have 8 files and 8 trace file, yep. And for FFT4, we will have 4 trace file, and we will use that in the later task. Now let's just say, let's have a look at the write-up. Okay, yes, here is the homework 8, and you can see there we need to use 4 processors for task 1, 2, 3, and 4. Okay, this is just fine. But for the task 5 and 6, yeah, you can see we need to configure the number of processors from 1 to 4 and 8. So this may lead a little change, little difference compared with the task 1 to 4. Let's just have a look. For task 5, okay, let's just say, let's open the SMP and split. I can't split. Oh, okay. Great, great. Okay, just as what we did before, choosing the protocol, SMP, MESI. You know, the number of processor here we will change. But for now, okay, let's change from 1, okay? From 1, start with 1, and this should be LRU, okay? Okay. And the next is wide 16, what about block 32, blocks in memory. Okay, just set it as default. Okay, no change. And for blocks in cage, yes, 256, mapping set associative, cages set 64, great. Replacement LRU, great. So let's have a look again. We said the configure main memory and caches as default, and you just need to do a little change for the multiprocessor. Start with 1 processor, and okay, just go like this. And then what we need to do for each configuration, obtain the global miss rate using the FFT simple and value. So that's a little difference from what we did before. Okay. We may need to use 4. We change the processor's number into 4 to have a look what's the difference. Okay, open main memory traces. For the project 1, the homework 4, I think you did before, we just go like this, right? Open the trace menu, and then we select the SPR. Okay, for the 1 unit processor is for the PRG, and here for the task 1 to 4, you need to use the SPR. But what's the difference for now? I mean, let's change into 8. You can see the FFT or simple or all these 4 trace files, the number of processor is fixed. You cannot change into 4, right? If we want to use it, like we say we want to use 8 processor, then can you use this trace file? No, of course, because the number of processor is 4 instead of 8. That's different from what we want. We are wanting to use 8 processor, right? So that's different. And also you can change this 4 into 1 and 2 by using this original tracing file. So today, what's important, start here. is use the trace file, we download it. So how can we locate to the new trace file? I mean, you just want to find it and find it on your desktop or anything and anywhere you may save the file. Okay, where is it? User, okay. See, yeah, user here, and then desktop. Okay, just go something like this. You want to find the file the zip folder you download, right? Yes, and then you will get this three folder, okay? Just as what we did, what we downloaded. And now we are taking an example for the FFT, 8 processor of FFT, okay? FFT, FFT8. You know, here 8 means there are 8 processor. We are using 8 processor. And each processor, you need to assign the trace file correctly, right? Because we are having 8 processor. Assign them, assign them, assign. 6, 8, 4, 7. Okay, so this is the correct assign the trace file for A processor start with P0 and with P7. I named the file from 1 to 8, but you should know there are 8 files totally. Okay, and check again. Are we doing everything great? Yes, yes. So just go like OK. Here also OK. And then what's the difference for what you want to see is we need to view the multiprocessor, right? Instead of the cage. Because for the project one, you can have a look of the cage or multiprocessor because they are the same. They are the same because we are using uniprocessor. But now if you watch it just cage, so you can see they are different. We have 8 processor. If you're just watching the result from a cage, that means you just have the result from only one processor. But we want 8 processor, the result of 8 processor, right? So remember, you need to using this multiprocessor instead of the cage. That's what we want to view, what we want to see, the result. Okay, it will show something like this. And check again, is the total number correctly with the write up. You can see here, FFT, yeah, the number is totally correct, right? So go again like what we did before, completely execute. Okay, it just will run. You can see the hit and miss. And what we'll focus is in, let's go back to task 5. Global miss and rate, miss rate, just miss rate. Okay, global miss rate. Okay, just get it. And this is for task 5. And why we recommend you to be a group? Because task 6 is based on the data you get from task 5. And you can see this is a huge data. So it may run a little bit slow if you run it on your own laptop. So I would recommend you using the remote lab or your GPU or CPU is your GPU is in a better version. I mean, if you got 3070, you can run it a little bit faster, but it's better to use a better GPU. And let's talk about go back the task 6. Here, after we get the result from 1, 2, 3, 1, 2, 4, 8 processor, for each these three tracing file. And what we need is to compute something, you know. The formula is already offered to compute the bus traffic. You can do something, right? Compute and the JS traffic, and then the traffic per transfer. Oh, yeah. So where is this? This is in the bus tag. You can see the bus transfer, the bus transaction, right? And you just run like this. And after you finish the task, you get a result. So you need to both record this page and also the bus page. If you forgot to okay, to copy the final result of these two, so you may need to run this whole task again. I mean, run this whole trace files little task again. So it take a long time, right? So be careful for task 5 and 6. You need to record these two pages. Okay, it will just run, but I will just let us say you need to remember to get an output of this global miss rate and also the block transfer and block transaction in order to help you compute the what we want in the task 6. Okay, so if you are a group, you can do task 5 and 6 together for one people, and task 3 and 4 uh, with the second people, and task 1 and 2, 2 and 1 for the third person. So that would be a good teamwork. Okay, so let's have a quick look of the task 1 and 2. You can say configure the block. We are just change the blocks in cache, the number of blocks in cache. And since we just need to use the SMP, the processor only 4, so we can use the original processor, original trace file, I mean, right? Just what we did before. Instead of using the trace file downloaded from Blackboard, we just use the processor, the number of processors uh, from the original. But you may need to remember where is the original uh the path of the original file. So maybe I just forgot it right now. But you should remember. But anyway, for tasks 1 to 4, you just use the original traces files. So you don't need to focus on this new file. The new file just for the task 5 and 6. Okay. Mm. I'm trying to use the traces downloaded from Blackboard, but uh, it's not a good idea for task 1 to 4 because the data is huge, and this huge data just for task 5 and 6. Okay. Okay. Let's just say we did this as default, and we get the result from the task 1. I mean the miss rate, right? Global miss rate. And for task 2, yeah, for task 2 also we need to calculate the bus traffic, the block transfers, uh, I mean, uh, the addresses. So finally, we need to calculate the traffic per transfers. Yes, just like what we did before. Multiprocessor, okay, 4 caches. I mean, four processors completely execute. And you need to record the miss rate and also the block transfers and bus transactions. Okay, so That's why we need or recommend you to be a 3 people group. Task 1 and 2 for one people, task 3 and 4 for the second people, task 5 and 6 for the last people. But actually, if you finish task 1 to 4, you should have your team, your group member who need to do task 5 and 6 because he will use the huge data instead of the data already inside SMP. So if you finish task 1 to 4, you should have someone doing task 5 and 6. It may take a long time for only one trace value, like for FFT4 processor of the FFT, it may take like 2 hours, I guess, while using the remote lab. As you can see before, uh, when I run a processor for FFT, the the progress is nearly showing nothing, right? In 1 minute. So you should run more than 1 hour to finish one trace valve. And there are 4 multiplied by 3. There are 12. There are 12 little tasks, I would say, you need to do. So please help your teammate. Okay. Okay, that's all. If you want to review something, just review this video. Okay. Thank you.